So before we learn about ions and isotopes today, I just want to show you one way how we would write like all of our information for a particular atom. So like the symbol, the protons, the neutrons, the electrons. So go ahead and copy down basically this whole diagram here. Okay. So in the middle just goes the 1 or 2 letter symbol that we get off the periodic table. So if you would like, you can use sodium as your example. And then on the top left, it's like a superscript, but on the left side, this 23 is representing the mass number. Okay. So when you write this down on your notes, you should have like an arrow and show 23 is the mass number. And then if you want to shorten the words, you could just write the mass number is the protons plus the neutrons. Or you could just do P plus N for short. And then the number on the bottom left, this number is the atomic number. Where do you find the atomic number for an element? Here, but, well, on the periodic table, right? So this number just corresponds to the atomic number on the periodic table. And then if the atom has an electric charge, it'll have the charge on the top right, so it'll look like a superscript. If there's no charge, you won't see anything here. So if you want, you can just write net charge. So you'll either see a positive or a negative charge there. And the correct format is the number and then the symbol. Okay. Sometimes you might see symbol number, but really the correct format should go number first and then symbol second. So first we're going to learn about ions today. Ions are just charged atoms, okay? And that's a very specific vocab word. So when we use the word ion, we're like being purposeful with using that word. So ion means there's an electric charge. When we use the word atom, that implies that it's neutral, okay? So like from this point moving forward, atoms are neutral, ions are charged. And then atoms become ions when they gain or lose electrons, right? So remember, if we were to change the number of protons, what happens to the identity? It changes. So we can't change the number of protons. Do neutrons have a charge? Okay, so if we change the number of neutrons, it doesn't affect the overall charge. So the only option for an atom to turn into an ion is by adding or losing electrons. Okay, there are 2 types of ions. You have to know these vocab words. Okay, so cations are positive charged ions. Okay. How you can remember this, do you see like the T in cations? Do you see like the T kind of makes a plus symbol? Okay, so like if you need help remembering, cations are the positive charged ones. Also, is anyone in here a cat person? Like you love cats? Really? Okay. Some people in the past, like if you're a cat person, they're like, cats are positively awesome, or you have like positive feelings towards cats. Okay. So cations, positive ions, you have to know that. Okay. In order for an ion to get a positive charge, it means they have to lose electrons. Negative ions are called anions. Okay. In order for an ion to get a negative charge, they have to gain extra electrons. Okay, so here's just an example of ions and how they form. You do not need to write this down, but I want you to look up here. Okay, so follow this with me. Okay, so here we have hydrogen with a plus charge. If the charge is ever like +1 or -1, you don't have to write the 1s. So it's just a plus. So that means it has a +1 charge. Okay, because it is a +1 charge, it means that there has to be 1 more proton than there are electrons. Are you allowed to change protons? No. So it means that you have to lose 1 electron. Okay. Let's maybe diagram that. So let's just say we have like 3 positive charges. If it's neutral, 3 negative charges. Does a positive and a negative cancel? It's like, do those cancel each other? Okay, so if we want to end up with like an overall positive charge, you would have to remove an electron. Does that kind of help visualize it? Good. Okay, let's say magnesium has a +2 charge. Okay. That means that there has to be 2 more protons than there are electrons. So how many electrons do you have to lose? 2. So I'd have to take away an additional electron. Let's say you have a minus charge. So fluorine with a minus charge. Okay. It means you have 1 less protons than you have electrons. Okay. So if I go back to neutral, if I want to turn this to a negative charge, it means you have to add an electron. Okay. So the atom has to gain an electron. Let's say you have to have a minus 2 charge. You have to have 2 less protons than you do electrons. So you have to add 2 electrons. Okay, so let's practice. We're going to count protons, neutrons, and electrons for the following ions. So the first one is just oxygen. Okay, so I want to see you writing this down, either on paper or your iPad, but I want to see everyone doing this part. Okay, so find oxygen on the periodic table. How many protons does oxygen have? Good. 8. Since it's been a few days since we've done neutrons, let's do neutrons in a little bit more depth. What's the atomic mass of oxygen?
8, 16.
Okay, 16. And then what do we have to do with that number? Okay, so what's 16 minus 8? Okay, so 8 neutrons. And then oxygen has that minus 2 charge. So it means it has to have 2 more electrons than it does protons. Okay, so 10. Good. Okay, are we ready to try the second one? Okay, second one is tin with a plus 2 charge. Okay, so find tin on the periodic table. Its symbol is SN. Okay, so tin has how many protons? 50. I'm going to do neutrons off to the side again. What's the mass of tin? Okay, first I'm going to do the decimal. So the periodic table is 118.71, yes? Okay, so then what whole number is that going to round to?
19.
Okay. And then now what do we subtract from the 119?
50.
Okay, so what's 119 minus 50? Do the whole number.
69.
Okay, so 69 neutrons. And this time for electrons, it has a plus 2 charge. So there has to be 2 more protons compared to electrons. So how many electrons? Good. 48. Okay, you try the last one on your own. So try phosphorus with a minus 3 charge. How many protons for phosphorus?
15.
Okay, 15. How many neutrons?
31.
31 minus 15, which is, okay, 16. And then if there's a minus 3 charge, what does that mean for electrons? Okay, add 3, so how many total? 18. Good. We're going to at least draw the aluminum with the plus 3 charge. So before you draw, do you have to know your protons, neutrons, and electrons? Okay, so how many protons for aluminum? Okay, 13. How many neutrons? 14. How many electrons? 10. What goes in the nucleus of the atom? How many protons? Okay. What else goes in the nucleus? Okay, and how many neutrons? Okay, so now where do those electrons go? Okay, how many electrons go on the first ring? 2. How many can go on the second ring?
8.
Okay, and how many are we actually going to draw on the second ring? 8. Okay. And notice I'm going to stick to that 12, 3, 6, 9 pattern, and then I'll go back and I'll buddy them up. Okay, so when we draw out the ion for aluminum, what do you notice about its number of valence electrons? There's 8. And how many does it want to have? 8. Okay, so that's the whole point of why an atom's going to gain or lose electrons. So if we were to draw out nitrogen with a -3 charge, how many valence electrons would you expect nitrogen to have? 8. Okay, does that make sense? Okay, so we would expect the nitrogen one also to have a filled shell. Okay, that's the whole reason why anything's going to have a charge. Okay, they're all going to have a filled shell. All right, so we're going to switch gears to isotopes. So ions are when you change electrons. Isotopes are when we change neutrons now. Okay, so get the definition down for isotopes. So they're just elements. They have the same number of protons, but then these ones are going to have a different number of neutrons. Here's an example of hydrogen. Okay, so hydrogen, if we were to look at hydrogen atoms, they come in 3 different forms or 3 different versions, okay, 3 different isotopes. So in the middle is our nucleus, so they can have protons and neutrons. Okay, so they're the same element because look, they each have 1 proton. So if it's 1 proton, is it hydrogen? Okay. But then they're different in the number of neutrons. So this first one has 0 neutrons, this second one has 1 neutron, and this third one has 2 neutrons. Okay, so that's all isotopes are. So same number of protons, different number of neutrons. So then let's recall back to last week. Do you remember last week I had you write down a table with protons, neutrons, and electrons in it? And we put down their charges and their masses. Okay, which 2 subatomic particles have a mass of 1 AMU? Look at your table that you wrote down last week.
Shucks. That giant thing is in that paper.
This thing? Yeah, so which ones have masses of 1? Good. Protons and neutrons. Okay. So because protons and neutrons have a mass, different isotopes are going to have different masses. Okay. So for example, protium is just 1 proton. So how much does 1 proton weigh? Just 1. Okay. 1 AMU. Deuterium has 1 proton and 1 neutron. So what would deuterium weigh? 2. Tritium has 1 proton and 2 neutrons. What's tritium going to weigh? 3. Okay. Can we see different atoms? Can we see the number of protons and neutrons they have? No, right? They're so tiny. We can't see them. So mass is how we tell them apart. Okay, so the way we can distinguish different isotopes is they're going to weigh different amounts. Okay, so then when we look at isotopes, we're going to care about mass number. So mass number is just your number of protons plus your number of neutrons. And it's super easy. They're both worth 1 AMU. Okay? And they're always going to be a whole number because can you have 0.22 of a proton or 0.22 of a neutron? Okay, always a whole number. Last week we kept things simple and we talked about the most abundant isotope in the future. So from this point moving forward. If we're looking at one of the less popular isotopes, we're going to start stating that. And we do that by putting the mass number after the name. So how many of you have heard of carbon-12 versus carbon-14? Maybe in the context of dating things in the past. How do we know how old things are? Have you ever heard of carbon-14 dating? Okay, so when we do this carbon-14, this is the mass number. And it's telling you we're looking at this specific isotope of carbon. So if mass number is protons plus neutrons, we can figure out protons and neutrons from the mass number. So if you look at the periodic table, how many protons are in carbon? 6. Okay, so if protons plus neutrons is 14, and 6 of those are from protons, how many neutrons are there? 8. You just subtract. Okay, so let's practice again. Protons, neutrons, electrons. So this time we're going to do copper 65. This 65 is telling you the mass number. So if you need to write yourself a little note, write yourself a note. Okay, so find copper on the periodic table.
29.
Okay, so how many protons for copper? Okay, 29. This time, now that you're given the mass number, we're no longer going to round the mass on the periodic table. Okay, so you're now using this number. So what's 65 minus 29? Okay, that's now your number of neutrons. And then if you look at copper 65, do you see any charges? Okay, so that means it's neutral. So how many electrons? 29. Protons better equal electrons if it's neutral. Okay, let's try another one. This time I'm going to add in an ion. So this one's chlorine. I'm giving it a -1 charge, and I'm giving you the mass number of 36. So find chlorine on the periodic table. How many protons in chlorine? 17. Then we'll do neutrons. So because I gave you mass number, we're no longer rounding and subtracting from the periodic table. So we're going to use this number. So what's 36 minus 17? Okay, 19 neutrons. And then chlorine has a -1 charge. So what does that mean for number of electrons? You have to have one extra electron, right? You have to have one extra negative charge, so you need to add 1 to this number. So there should be 18 electrons. The last thing I want to teach you today is how do we get the number on the periodic table? So where does like the average atomic mass come from? So let me start with like an analogy for you. So let's say I give a chemistry test. Half of you get 100% on the test. And then half of you get a 75% on the test. What's the average? So the average between 75 and 100 is 87.5. Did anyone actually score an 87.5? Okay, so the same thing works for averages on the periodic table. So let's keep looking at copper up there. We were just looking at copper. Copper's average atomic mass is 63.55. But does any copper atom actually weigh that amount? No. It's just an average of the different isotopes of copper. So to figure out the average atomic mass, you have to know the number of stable isotopes, the mass of the isotope, and then the percent abundance. So we're going to put that in a formula. So you need to write down the formula down here in bold. So the average atomic mass, it's equal to M1, and M1 is just the mass of the first isotope. And then you multiply it by P1. P1 is the percent abundance. Okay, and then here's like the key though. The percent abundance has to be in decimal form. So if you want like write that really big, like it has to be in decimal form. We'll do an example and I'll show you what I mean, but like write this in your notes. And then we add it to M2 times P2. So M2 is just the mass of the second isotope times the abundance of the second isotope. And then what do you think this plus ... means? Can there be 3 isotopes? So if there's 3 isotopes, you'd keep going, right? If there's 4 isotopes, you'd keep going. So does that ... make sense? Okay. All right, so rubidium, it's a soft, silvery white metal, and it has 2 common isotopes. So 85 rubidium and 87 rubidium. If the abundance of the 85 rubidium is 72.2% and the abundance of the 87 is 27.8%, what's the average atomic mass? Okay, so in order to do these, you have to know the number of isotopes. So how many isotopes does rubidium have? Read the first line. Okay, 2. And then you have to know the masses. So the masses are the 85 and the 87. Okay, so when you see those numbers like right before, right after, that's their mass number. And then you also have to know the percents, which are also given to you. So now we're just going to plug it into the equation you wrote down. So what's the first mass number given? Okay, so it's 85. and we have to multiply it by the percent abundance in decimal form. Okay. So the percent abundance is 72.2%. How do we take a percent and convert it back into a decimal? Do you ever talk about this in math?
Probably. I'm gonna guess we did.
Good. You divide it by 100. So can you type in 72.2 and divide it by 100 in your calculator? Okay. Or there is a much easier way. It is the same thing as moving that decimal 2 to the left. So can you just move the decimal 2 places to the left? Okay, so what does that become? Okay. So 72.2 becomes 0.722. Yes, do we feel okay with that? Okay, then we're going to add that to the second isotope. What is the mass of the second isotope? 87. And then we're going to times it by the abundance. But what do we have to do with this percent? Okay, you have to convert it back to decimal. So you can type it into your calculator. You can divide by 100. Or how do you move the decimal? Okay, 2 to the left. So either way, what number does that become? Okay, 0.278. Okay, now I want you to practice calculating. So practice typing this in either like a real calculator you'd use on a test or Desmos. And if I would use the parentheses so it does your order of operations correct. Keep going. Okay, so we're getting like 85.556. Okay, I would say like if we had at least like 1 decimal or like 3 sig figs in the percent, let's go at least 3 sig figs. So what could we round this to? Okay, so like 85.6. And when we talk masses, the unit is AMU.